Hello, and welcome to this Manufacturing and Technology virtual presentation, From Legacy Machines to Manufacturing Intelligence. Today's presenters are Myckel, Haghnazari, and Tallis, Blalack. Myckel is Director of IT, leading the Digital Factory Initiative at Flex, and Tallis is Vice President of Marketing and Business Development for Arch Systems. Their full bios can be found by clicking the speaker profiles below. Throughout the presentation, we encourage you to interact with our speakers and each other using the Q&A chat to your right. Welcome, gentlemen.
All right, thanks. My name is Myckel Haghnazari, Director of IT at Flex, leading the digital factory space within the IT. I've been with Flex for about 20 years in various roles. In the last 2 to 3 years, I've been really focused on the digital factory space.
And my name is Tallis Blalack at Arch Systems. I've been paired with Myckel on our global rollout inside of Flex.
Okay, so let's jump into it. So first, a little bit about Flex. Flex is a $24 billion company. We have over 160,000 employees that operate in about 30 countries, and we're across 130 facilities around the world. And as you can see on the slide, we work with over 1,000 customers and about 16,000 plus suppliers. One of the things that a lot of folks don't really know about us is that we also have extensive domain expertise in design and engineering, which we leverage to help our customers. I also want to go over the industries that we deal with a little to help put in context the type of environment that we work in, especially in relation to the initiative or the topic that we're presenting here today. As you can see, we have domain experience across 6 industries and numerous sub-markets. The takeaway here is the fact that we deal with every industry and product that you can think of, whether that's in the consumer devices space or automotive or even healthcare. So when you think about Flex's environment, you're really talking about the environment of almost every industry out there. So what I want to convey here is that our facilities, the machines within those facilities, the technologies within those facilities that run in our factories could be vastly different from site to site, process to process, depending on the type of industry that we're working in. So when we talk about digital factory and unifying our data across the globe, the complexity of this is exponentially higher than if we were talking about doing it just for one product or for one industry type. So with that laid out, let's dive into the initiative and the topic we're here to cover. About 4 to 5 years ago, we started discussing Industry 4.0 and the topic of digital factory. In fact, one of the main pillars or overarching initiatives within Flex became Industry 4.0 and digital factory. I do want to highlight that the initiative that we're covering here is one of the many programs that fall under the 4.0 umbrella. Specific to this topic, the goal for us was to focus on the fundamental or foundational pieces that would help drive or enable many of the overarching activities within digital factory space. What do I mean by that? Our goal was to digitize the machines on the factory floor, or another way of saying it, the goal was to figure out how to tap into our high value assets in our factories, expose the data, and expose it in a way that could be consumed or leveraged for multiple use cases. So as I've outlined on the slides, the objectives of this initiative became aggregate data across all machines and machine types, automate machine utilization, aggregation, and analysis globally, as well as enable advanced analytics and automation capabilities. Now, when we went into this, we knew that many of our factories or facilities across the world have done some level of this type of work, essentially tapped into the data required to run their operations. However, all the data is sitting at the edge. Also, the data, let's say the data collection process, the method of aggregating that data is all different and in different formats, pulled in different methods. And in many cases, it may be, let's say, an incomplete picture of the environment. So what we're really attempting to do here is not only figure out how to access that data from the various machines and facilities, but also aggregate it globally for analysis. And as I mentioned, we want to try to do this in a format that could be leveraged for multiple use cases. Obviously, this has many applications or use cases, I should say. For example, if we have visibility into the global data set, then we can easily track underutilized assets. We can see where we have capacity to drive more business in. We can do some correlation analysis across machine types, models, setup, recipes, etc., as well as figure out failure patterns or opportunities of improvement. So the possibilities of aggregating this data becomes endless. So as I mentioned, we're in over 130 facilities. We deal with multiple industries that cross the gamut of products produced at Flex, from assembling phones to producing products that deliver insulin to making carpets that go into your cars, which again makes the landscape that we're dealing with extremely challenging. For instance, if you take our SMT landscape, we have over 15,000 machines. And those machines are all from different vendors, purchased in different years, operate on different hardware. They have different software, as well as versions and variations of those software. The same is true in our non-SMT space. We have over 3,000 machines, and these are really our what I call our high value assets. There are thousands more that are not in our radar in terms of this initiative. But again, these assets also come from multiple vendors, have their own technology and challenges. And in particular, in this space, in the non-SMT space, we also have machines that don't really produce data. They don't have a database. They don't have methods of pulling data out of them. So as we started to think about our strategy in how to tap into the data across all the machines and machine types, we also had to consider our approach for mining data from machines that really don't produce data, such as some of our bending and turret and gluing and plastic injection molding machines. All of these machines, depending on the year, depending on technology, may not have methods of giving us data. So when we thought about our challenge, we knew we had levels of experience within Flex that could help. However, we also knew that in order to complete the entire picture, both on the SMT and non-SMT side of the house, we needed a level of focus and dedicated resources that could, that I should say, had cross-domain knowledge of machines, of the operations, of IT, as well as, since this is a data game, if you will, as well as be experts in the data mining and analysis side of the house. So as we set out to augment our resources with external partners, we had those criteria in mind. We also had, I should say, we are, at Flex, we're also very practical in how we vet out our vendors. In almost all cases, as far as I've been here for 20 years, we essentially have real live use cases where we challenge our vendors, where we just throw them at the project and say, go figure it out. If you can do it, then you can move up to the next level. So Now, I don't want to go through all the vetting process of all the vendors, but I'll give you a, let's say, quick version on how we landed on Arch, which I think is a good testament to their culture and capabilities. A few years back when we had the Nike account, we had several types of machines that were where we were attempting to pull data from to make our processes and machine utilization more effective or more efficient. In fact, there was a case where we were working with a particular vendor for about 6 months, where we were asking them to help us pull some of this data out so we can, let's say, more efficiently utilize their machine. This was right around the time that Andrew, the CEO of Arch, and Tim Burke, the CTO of Arch, had let's say, recently presented their version of the connected factory to us. So we said, fine, we have a challenge for you. We actually sent them both straight down to Guad, our facility where we had the Nike lines. We pointed them at a few machines and said, can you get us data? Long story short, sure enough, Tim, their CTO, came back with solutions and data within a week or so, including the data from the machine that we were struggling with over 6 months. So at that point, even though we knew they were a startup, we also knew that their expertise and their can-do attitude was the right fit. So with that, we said, fair enough, let's partner up, but we'll try to do the overarching initiative of digitizing our entire global factories versus just specific to that product line. So we partner with them and let's say, like I said, set out to tackle the bigger initiative, which was to digitize and connect the data across our factories. We outline our goals and we're very specific into what the end vision would look like. In the space of line utilization and asset utilization, we had let's say, we call it tactical goal, in that we asked them to deliver a solution, or I should call it application, that would provide real-time visibility into all of our assets and our asset utilization. So again, coming back to knowledge of operations, knowledge of application development, this was one of the initiatives that we set out with them. Additionally, we outlined a strategic path where we wanted to make sure that the effort that we're embarking on is scalable and ultimately enables our internal teams to leverage the data that we're gathering for multiple use cases, right? As you can see from our slide, you got your SMT, mechanicals, you got your masks, and in the other space, we have other, let's say, initiatives that we're currently working out with them, but we knew this is where we wanted to go. So in terms of the strategic goals, I do want to highlight this. This also helps us drive clean and consistent data into our Flex system. So this was one of our priorities, especially within IT. We knew if we can grab the data in a consistent manner, it'll reduce the redundant effort across the sites, because we know at each site these guys are also trying to get that data. So if we can do it, it reduces the redundant effort. And as well as it gives us clean data. And furthermore, it allows us to standardize on an IoT device, since a lot of our factories, or I should say a lot of our sites, also attempt to, tap into the data on the mechanical side and grab that data and try to push that data into our downstream solutions. So with the strategic, let's say, initiative, it helps us in several, let's say, in several manners. Now, with that said, I'll pass it over to Tallis, and I'll come back and discuss a little bit on the results.
Thank you, Myckel. So just a quick reminder, Tallis Blalack with Arch Systems, and I'm going to be talking about our machine data and analytics for SMT and discrete manufacturing. So I'd like to start with a little bit of background on Arch Systems. So our two founders pictured in this slide are Andrew Schuerman, our CEO, and Tim Burke, our CTO. They met at Stanford in the PhD program for materials science. Andrew was working on building semiconductor atomic layer deposition machines, while Tim was working on organic solar cells. Andrew also started working with StartX, which is Stanford's startup accelerator. And he helped build the hardware vertical for StartX and worked with a lot of IoT and hardware startups. In Tim's background, he was in the Peace Corps before he came to Stanford. So while he was at Stanford, he also started working with a nonprofit in Africa that was trying to figure out how do we monitor our wells and water systems that are being put in, because at the end of the first year, a majority of them are no longer working. And so it was a challenging problem for Tim. You had a lot of different types of systems. So he ended up building prototypes of hardware to monitor that. Because he had the different systems, he built a modular fashion that he put together. This ended up going on a number of systems in Africa that eventually ended up monitoring the water for 10,000 people in Tanzania. So Andrew saw this hardware that Tim was working on, and they got together and in 2016 launched Arch Systems, which is a hybrid for-profit, for-impact focus. So the hardware that we develop for working with companies like Flex, we actually provide to nonprofits so they can monitor water systems, so they can look at electricity usage for different machines in Africa and try to understand how can those be powered by more environmentally friendly renewable systems, monitoring electricity usage in India, a number of different organizations that we're working with on that side. But on the commercial side, Flex was our first global manufacturing deal. We started working with them in 2018. As Myckel has been talking about, we've been rolling out across through their factories in the world, many different countries, many different types of machines. And at this point, we're the emerging leader in the global EMS and analytics space. So today, we have a platform we call ArchFX, which is for data gathering and advanced analytics. So we can extract and analyze data from any machine type, new or legacy, real-time data, and predictive optimizations. For the EMS space, customers like Flex, we're in facilities of 4 of the top 10 global manufacturers. In the semiconductor space, we're working with 3 of the Fortune 1000 manufacturers, and we are working with 1 top 50 OEM and helping them understand their product being produced in a factory on the other side of the world and giving them visibility in what's going on. From the team side, in 2016, Arch was the top startup out of Stanford. I came in from the semiconductor space. Our VP of engineering came in from 20 plus years in the semiconductor industry, bringing a little different background and expertise to the team. And there are 3 areas that I want to highlight today of expertise at Arch. One is what we call machine whisperers. So being able to understand what's going on with electrical, mechanical, computer-based systems and being able to get data out of them. Understanding what to do with the data after we have it, having physical science PhDs skilled in machine learning and artificial intelligence, and as also I mentioned, expertise in electronics and semiconductors. So when we started with Flex, Myckel mentioned the Nike engagement. We did a little bit of that at the start as well. So at a different time, we can talk about how do we pull data out of a sewing machine. But what I'm going to talk about now is getting data out of these surface mount technology lines. So this is, when you look at your electronics, you see the green boards that have integrated circuits on those. Those are what get populated and get built in an SMT line. As Myckel mentioned, they have over 15,000 machines that are in these different lines across the globe, very large capital investment, and the basis for a lot of the revenue that Myckel mentioned. There is a Flex site in Milpitas, California, here in Silicon Valley. We're based in Palo Alto. We started there. It allowed us to walk the lines, see the machines, work with the local operations team, work with the local IT team as we get everything installed and hooked up. We started by tapping the SMEMA interface between the machines. And this is just the handoff protocol that's used to let one machine know when the machine before it is done, hand the board across to the conveyor into the next machine on down the line. So we built custom hardware to tap into the SMEMA interface. In the picture, you can see where I have a circle around the SMEMA ports for our accessory that's built in there, connecting up to our pod that's broadcasting out the information from that. And we're able to capture the boards moving down the line. So this gives us, the utilization, gives us availability of the machines. It allows us to calculate cycle times, understand where work in progress is, basic machine utilization, but there's a lot of information that you can pull out of that. What we found as we got into that was we could easily get the data in Milpitas. We went down to the facility in Guadalajara. It wasn't a problem. When we got over to China and started rolling out in China, what we found was that the local conveyor machines were not built according to the standard. They had removed the SMEMA plugs because they're expensive, saved them cost. But instead of us being able to go in and literally plug into one of the conveyors in 30 seconds and not stop production, we then had to stop the lines. We had to actually take some of the machines apart to connect inside of the machines to get everything in place. So a lot longer to be able to put the hardware in place and a lot more work. We also found that the SMEMA data was very noisy because each vendor had their own implementation for the standard. And so as we're trying to capture the voltage signals, the handshake as it's going between machines, we had to do a lot of setup time. We built our own hardware to be able to understand what was happening. And it took us a long time to adjust for each machine going down the line. So at the same time we started the SMEMA installation, we started a parallel path for being able to pull digitally data out of the machines. So a much richer data set, much smarter connection into the machines. And we transitioned to the pick and place machines. And we started pulling in this much richer data set to fill our data lake. So one of the pieces that you see when you get into these larger IoT implementations is that you have to be able to adjust on the fly because things will change as you're going through. And one of the things that it meant for us is that we had to explain to the sites why we changed plans. A little loss of credibility. You come in with one plan and now you're switching to another. But as you go through, you've got to be able to regain that credibility and get their trust. So we're in the middle of a global rollout across the Flex sites. We chose by connecting all of the ASM pick and place machines. The pick and place machine is the autonomous robot that picks all of the little components and puts them on the board. You can have these machines doing more than 200,000 placements per hour. It's the most important and the most expensive machine in an SMT line. So we started with kickoff calls with all of the regions explaining the plan. We had people from IT, we had people from operations. We made sure that we had visibility to the general manager for each site. Each site filled out a readiness report with basic information. So what are the IP addresses that we need to connect into, et cetera. We remotely probed each site to understand what the real status was of the lines there and had to work through with each site to go through all of the connection issues. Make sure that the right ports were open, make sure that some of the intranet sites were opened up so we could speak to the broker that we put in the Flex data centers and be able to get the information out from the sites. We also ran through, different versions of the software and had to plan that through that. So sites that had to upgrade the software took longer. We're currently finishing the ASM rollout across the globe. We're starting the rollout with Fuji, which is another pick and place vendor. And we're also pulling data from the Panasonic pick and place machines that Flex has intermixed in these sites as well. I want to take a minute and talk a little bit about the technology that's behind this, because that will help you understand what's going on as we are implementing our data extraction solution. So the first step is for us to get the data from the machines. And we need to be able to extract the right data, and we can do that from any machine, new or legacy. So on the SMT side, as I said, we started with just a simple hardware connection, but we moved to rich data connectors that we're using now. On the mechanical side, I will talk about this in more detail later, but we're using a very simple data connector where we're connecting to the PLCs on the machines and pulling out the job complete signal and sending it into the mechanicals MES Pro system that Flex uses on the mechanical side. So once we have the data, we need to transform it into the same language, because different machines speak different languages. And if you pour all of this into the data lake and it's not standardized, then you have a problem trying to do any analytics on top of it. So the data gets pulled up into the ArchFX broker, it gets loaded in and standardized. From the broker, we can now run real-time dashboards on the site. So Flex has 3 primary data centers across the globe, one in Europe, one in the Americas, one in Asia. So we're running our broker on virtual machines in the Flex data centers from a regional point of view. We also have connections into FlexFlow, which is the MES system for the SMT side of the house, and for MES Pro on the mechanical side of the house. At the same time, we're sending a copy of the data to the cloud, which allows us to do much richer analysis on top of that. So in terms of enabling scalable business intelligence, we can develop custom reports. We can set an interface so if Flex wants to pull out their own reports using a tool like Tableau, they can easily do so. And we also generate a global KPIs application for key process indicators. I'll show a couple of screens of that here in a couple of slides. Finally, with all of the data in the data lake, we can now start going through that and using machine learning, using artificial intelligence, pull out some of the advanced analytics that really let you see some of the value from the data that we're collecting. So if I put all of this together and talk about it, 3 enabling technologies: being able to pull data from any machine type, being able to transform it into a consistent structure that we can then load into the cloud. In terms of the solution tools, being able to build real-time dashboards, being able to connect to the MES systems, custom reports, global KPIs, and as I mentioned, the advanced analytics. Here are a couple examples of global KPIs dashboards. These are not dashboards from Flex. These are dashboards that we've anonymized. If you actually look closely, you can see this shows no data coming in from Europe, and we're connected into a number of different European sites for Flex. But this gives you an idea of how we put this together from an overall point of view. So you can see regional data, what's happening. You can see what's happening from a global point of view. Little map giving you an idea of where things are and the size of different sites. And then we have a list of the different sites. If you click on the name of any site, it will bring up a site level dashboard showing you what's happening at the site. At the bottom, from the global point of view, we also have top 5, bottom 5 sites, just from a quick visualization of what's happening. On the right-hand side of the slide, you can see a line view. So if you go into the area view from a site, you can click down and you look at individual lines. In this case, we're looking at the line utilization from an SMT line. You can see what the target is. You can see what the actual production is with respect to that. You can see a listing of the different machines that we have on the line. If you click on a machine, it will bring up more information about that, and you can pull up actual details on the machines themselves. There's a date picker in the upper right where you can select, do I want to look at this on a daily basis, a weekly basis, a monthly basis? Do I want to look at a custom, gathering and understanding what's happened over those time periods? But this is a way that for the senior execs, for the people that are running sites, they can quickly get an idea of what's actually happening in their specific facilities or across facilities. And in the age of COVID, when we can't travel, this becomes an increasingly important tool to be using and understand what's happening. Let me spend a few minutes and talk about the mechanical side of the house. So many different types of machines, and we talk legacy machines. Some of these are machines that have been in operation for more than a couple of decades. We're also talking, as Myckel said, lots of different types of operations going on among the many business in Flex. So metal cutting and bending, stamping machines, heat presses, stamping out carpets for automotive, injection molding machines, which are plastics, being out different types of plastics for many different applications, lots of different machine types that we have to be able to connect into. We do a wireless connection to these because it's a much lower cost of installation. And we built custom hardware for this as well. So we have an opto-isolated accessory that we use to connect into on many of the machines. We also have a non-isolated hardware solution that's often used with relays and others. We typically connect into the 24 volts on the PLC that we're monitoring, but you can bring in external power as well. And as I mentioned earlier, we're kind of capturing the job complete signal that you have. And we've been able to do this on a fully remote installation. So when Flex's Shanghai facility opened up post-COVID, we completed our first installation in that facility. Never were able to step on site because of COVID. We're able to work through all of the installation challenges, get everything up and running, and the site is operating very efficiently using the technology. I will also mention in the bottom right corner of this picture, you can see where we're connected into one of the mask making machines that Flex had built for COVID. So they had mask making machines that they had built for them that they shipped in different installations across the world so they can produce masks, not just for their employees, but also the excess masks can be donated to the community. And we've connected into those so that they can globally see what's happening as they're producing masks across the sites. On the mechanical side, MES Pro is their manufacturing execution system for that. So we connected into MES Pro from the machine. We connect to the PLC, our Pod 1C that sits on it, sends a Bluetooth signal to the access point. And I know that some people are going to say, can you handle that in noisy situations? We've been in very noisy environments, especially in some of the mechanicals operations. There's enough redundancy built into the system that we can capture those counts. That gets sent inside of Flex's network to the broker that's sitting in the regional data center. And then the information is sent back to the on-premise MES Pro system. So there was a lot of concern as we first started putting this together of, will there be latency issues? Will there be anything else? We've had zero problems with that in terms of being able to get the data to the system. This replaces the pen and paper counting system that was being used in most of these. In some of the places where they had already been connecting machines up to MES Pro, they were using a wired solution, and the wireless solution is just much easier to put in place. Once the information is there, now they can do automated scheduling. There's a lot of additional capabilities that allow them to improve the productivity using the MES system. And we're also sending a copy of the data to the cloud to provide global utilization, and once again, a view from someone looking across different facilities and understanding what's happening. Want to talk a little bit about some of the challenges that we've had working across this. As Myckel mentioned, Flex is a very large, very diverse organization, and it requires a lot of coordination for this. So Myckel spends a lot of times getting the right people together. But this would be impossible without the top level support for both IT and operations. So Gus, Flex's CIO, is 100% behind this and making sure that we're able to get the data out. And Francois, the COO, has said that he wants to have this in place across his entire organization. Even with that support, that doesn't mean you don't have challenges as you get down into the local level. And when we first started off and we're pulling out just machine utilization, that alone doesn't add immediate value to operations. So you have less buy-in at the local level because they're saying, what do we get out of it? It just gives visibility to the senior execs. We have far less challenge at that now as we're able to show some of the advanced analytics, but it's clearly something that you have as you initially start one of these programs and you start getting it through. And you've got to just work with the teams to get everyone aligned. I mentioned the software upgrades early on. Well, if you're looking at an organization as spread out as Flex, there is no consistency of software or hardware across geographies. And what that means is that you have sites that are on older versions of the software that don't provide the same level of data for us to extract. Some of that software is tied into local implementations that they built in. And so upgrading the software can take time. Sometimes if it's old enough, you have to bring in new hardware, which means you've got to go through, get the budget for that and put that in. From a global rollout point of view, understanding that as much as you can from the start is really important, because it then lets you start that process so that everything's getting upgraded. By the time they have it upgraded, you've completed the other sites that have things in place so you can get everything working. I also need to mention that everything is being done remote. We're in the age of COVID, that's where we are. This normally isn't a problem, and we have been able to work through everything, but it does cause things to take a little bit longer when there are problems. So one example would be, we're working with a facility on the other side of the globe. You have limited interactions, in the morning and evening. And what it means is that the number of cycles you can go through to debug things and get things in place takes much, much longer. So where we would have gone in a different situation and spent a week on the site getting everything set up, getting everything in place, because you're not able to immediately resolve things and keep working through, that can stretch out in the case of months, a couple months, depending on how large the site is, how many things you're trying to solve as you're going through. So it does make things more challenging, but we've been able to work through them all. Now, before I hand this back over to Myckel, I would just like to say that we really appreciate the partnership that we have with Flex. They've been a great company to work with. And I really appreciate the work that Myckel has done in terms of getting the right people in the meetings with us, lining up the right opportunities. And we've seen, as we've been able to put this solution in place, as we've been able to show additional value, that other people inside of Flex are now coming forward and saying, can you connect up this machine class? Can you help us with this problem? And it really shows the value that we can create working together.
All right. Well, thanks, Tallis. I'll go over, where we're at and the results to date. As I mentioned, when we're in various pillars here in terms of handling different types of machines and in terms of our goals and what we're trying to accomplish. So broke it down into kind of four, let's say, segments or categories here. Starting off with SMT, and really the focus, I know I said, look, 15,000 machines out there, but really our focus was our high value assets where we wanted to track their utilization. So in this case, as of date, I should say, we've connected over 1,000 machines out there, which is a testament to the project, as well as testament to Arch's capability in helping us getting there, right? As well as all the Flex employees who have actually helped us there. So you got 1,000 machines connected, 200 lines across the globe. Arch has helped develop maybe, let's say, 15 different types of connectors. So as we move from site to site, region to region, we now have capabilities that are easily, put in place. On the non-SMT side, and I've clubbed injection molding machines and mechanicals and all that together. We now have over 150 connected machines, and these are also, as I said, a lot of these machines don't even have methods of pulling out data, and Arch has come in and translated the signals into unit counts, as well as Tallis mentioned, develop connectors so that we can push that data right into our MES solutions for those sites. And again, as he mentioned, and this is a big factor, I know we keep harping on it, but remote deployments is let's say a big win for us, right? Flying people around the world, it gets expensive, but we've managed, given the solution with Arch, we've managed to do all of these deployments remotely. On the application side, right, I mentioned before, we had a tactical initiative where we actually asked Arch to develop the application and the analysis around it. Arch, Tallis actually showed you the application. We now use that application to track our assets, and we've automated the gathering of those data points for those 1,000 machines that are connected. In addition to that, Arch has been helping, not only Arch, but also even our sites that are leveraging some of this data. We're running ML models. We're finding, different types of scenarios within those ML models. And as well as we now have a clean data set that we're working with. In fact, our Europe region has an instance where they're trying to do certain things, and they came to us and said, hey, we remember that you've connected to all our machines. Can we take a look at all the Europe region, and we want to run our own analysis on top of that. So that made things faster, right? We just pointed them to the Arch data lake, and they're now consuming that data and doing all kinds of stuff with that. Again, the last point on the application and connectors, it was important for us to be able to leverage those data sets and push those data sets into our downstream solutions, in this case, our MES systems. The last point here, data insight and analytics. Like I said, data, is the end game here for us, right? How do we leverage that data? So we now have over 1,000 machine parameters that we're tracking, right? And with that, and I'll just highlight two of those examples that Arch actually came back and said, look, we looked across your region, we looked across your machine types. We now can give you pick and place error rates by machine, by site, by, globally. In fact, it goes global, site, and machine. They can pinpoint the error rates down to that machine on that particular line. So that was very insightful. And so we're now doing a lot more work in that space. The other piece was, given that we have all this data globally, we're now able to do analysis on balancing our lines. Again, Arch, and I'll call out Tim again, their CTO, super smart guy, came back and said, hey, analysis on your machines. I looked at it globally. We can now track and figure out where you guys, can optimize on balancing your lines within those machines. So that's it. With that said, I'll pass it back to the moderator.
Thank you, gentlemen, for a great presentation. Again, attendees, please use the Q&A chat on the right to keep the conversation going. Hope you enjoy the rest of the day.
Okay, thank you.